All right. Number one, divide. What size box do I need? 5 by 2. It's going to be big. Have we done a 5 one yet?
Wait, is this for the box? Wait, we have to test it? Yeah,
Well, usually you can tell because if you're in the hundreds in the problems. But the test is a week from today.
What's today? Tuesday?
Yes.
That's not good. Thought my grade went down a lot from that quiz.
Well,
I don't even know what my grade is. Too scared.
okay. Let's see. This has got to be 49a to the 5th, 7a to the 4th, 42a to the 4th. Okay. Minus 35? Yes? Okay. Let's see if Mrs. Talbot could do it. One of the ways you know you're on the right track is it has to be divisible by 7. Otherwise, we're doing it wrong, right? Okay, so I have negative 30. I need negative 44, so I need negative 14 more. I have negative 12, and I need negative 40, so that's negative 28 more. Ooh, okay. Is it really 70? No. 70, right? No? Okay. Okay. Okay, so 70 minus 60 is the remainder. And the answer is 7a to the 4th minus 5a cubed minus 2a squared minus 4a plus 10 plus another 10 over 7a plus 6. Are we all thumbs up in agreement about Mrs. Talbot's attempt at mental math Tuesday morning? Okay. Now remember to be really careful here with the signs. On the quiz, some people did like if this was negative 60, they did 70 minus 60 instead of 70 minus negative 60. Gotta be really careful about the signs right there. Okay. Notice also the format of the answer. This is a division problem. This is not a factoring problem. So division answer is just the quotient piece. Okay, anything you want to say about number one? Okay, number two. Find and describe all zeros. First thing to do is make it equal to 0. And then zero product property. I'm gonna do these two with work. You probably, I mean, you might need to show work for that one, maybe not, but I do want to show work for this one for sure. So the 5 is one single real root. Minus 9, minus 9. Two single complex roots. Minus 1. Divide by 3. 1 single real root. Any questions about number 2? Are you sure? Yes, honey.
You have to write, when you say secret, you say, I don't know, this is real, or like. You know,
I do. I mean, on the test, I would just because it's a test. Like on your homework, I don't care. I mean, on my homework, I'd probably write two sin com, to be honest. Yeah, or one sin real or one sin But on the test, I would be like, display it. Okay. Number 3, completely factor, then find and describe all zeros. One root has been given. Okay, so if you're wondering how we get away without using a graphing calculator on a problem like this is how. We give you one of the roots to start with. Yesterday, when we did these in class, I had you look in the graphing calculator for a root. This time they give you one, but you need to see how to read the problem. So this up here is the problem, and then the 5 is the root they give you after the semicolon. So this is the polynomial up to the semicolon, and that's the root that they give you. Okay, so the first thing I do is change that to be a factor, and then divide. Now these, because you're factoring, you should get them to come out evenly every time. Not with a division problem, those have remainders, but factoring problems should come out even every time. Otherwise, you did something wrong. Or there's a typo. I'm not going to say that I'm above that because we all know. Mm-hmm. that right? Did I do it right? Okay. Yes, excellent. Okay, so that's factored. That's done with completely factoring. X equals 5, 1 double real root. X equals 1 single real root. And then if I was taking the test after a problem like this, I would definitely graph it on a graphing calculator and just check to make sure that it was actually a double at, like at 5 and a single at 1. That's how you can check your work before you go. This one would be a really easy one to check because they're nice numbers. What? I'm gonna divulge that secret information. I can't remember, actually. I made the test, I don't know, a couple of weeks ago. But are there any questions on the process here? So we talk about the process real quick. So I took the root they gave me, made it into a factor. I divided to get it down to a quadratic, which I can then factor with box and diamond, wrote my factors, and then found my roots. And how do I know that I'm done and I have all the answers? Yes, perfect. Number of roots matches the degree. Couldn't have said that better myself. Okay, so x equals -2. Are you halfway through this problem already without me? Most of you? Yeah, okay. X plus 2. Hmm. Yeah, yeah. What do you guys think? Diamond and boxable?
And I wrote with 10.
Did you guys really think I was gonna put two that were diamond and boxable right next to each other on the review notes? Come on now. You guys got I root 7? Okay, so let me get my two from up here. You could just make a little note off to the side if you'd rather. Did anybody graph this in the graphing calculator perchance? No, Mrs. Talbot, we did not do extra. It is 8:49 in the morning. What is your, I just wanted to see if the bump was at 3. That's all. Or I mean, not 3, 1.5. It is? Whoa, we might be onto something, people. When the students surpass the teacher. Amazing. Okay. So I think it would be best unless you learned the song last year to probably put the quad formula on your note card just to have it there. Unless you have it memorized or you know the song. Yeah, it's like Pop Goes the Weasel. Miss Maselli sang it. X equals negative b plus or minus the square root b squared minus 4ac all over 2x. It works. I don't teach math too, so I don't have to put myself through that very often, but there we go. My embarrassing moment for the day. Not football related. I okay. All righty. State the degree and end behavior, blah de blah, factored form using the point given. Excellent news. I like factored form. Okay, so this is a degree 4. Does that make sense? 1, 2, 3, 4 directions. And the end behavior is down if x approaches negative infinity, y approaches, x approaches infinity, y approaches. So they're both going down. Okay, now I'm going to come along the x-intercepts and make dots. I like to make dots on the x-intercepts because some people get confused about like where the bump is and what's necessary. If I could just focus my attention on those dots on the x-axis, that really helps me tune out the rest of the graph. But I do need to know that this one is a double. And I do need to know that that one's 0. So I'm going to start with y equals a. This one is 0, so I'm going to put an x in the front. This one is a double at -2. So I have x plus 2 squared. And this is a single at 5. Did I count that properly? I think so. Okay, now I'm going to put in my x and y. 27 equals a times 1 times 1 plus 2 squared times 1 minus 5. 27 equals 8 times 9 times -4, right? Okay, just, I don't know, it's weird, but it's fine. Reduce, divide both numbers by 9. Y equals -3/4 x, x plus 2 squared, x minus 5. Now, I would not ask you to put that one in standard form. Do you understand why I would not ask you to put that one in standard form? Because a is a fraction. So, but if let's just say we would do a box for these two. So x plus 2, x plus 2. Take your answer, do a box with this. So it would be a 3 by 2, and then distribute. Any questions about number 5? We good? Okay, last two, your fave, standard form. Okay, now these do not have solving for a in them. They're just, also, there's missing a space right here. Just pretend there's a space there. Function in. That's a new word for today. Function in. Write a polynomial function in standard form of least degree with integer coefficients, blah, 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 blah. Okay, so y equals. Now this one doesn't give you any points. It doesn't say anything about solving for a. So I'm not going to put the a in the front. Just going to go with x minus 4 double x minus 5. You see the language for the double. Okay. $80? 50 plus 30, 50 plus 30 is 80. Man, that was an easy one of those. Assuming that my mental math is called correct. Got the easiest possible to the hardest possible over here. But do you have any questions about number 6 before we move on? Do you see where that went to the double, switch the signs, boxes? Everybody good? You sure? Number 6? Okay, now let's do the spicy meatball. Oh my, just wanted to be done so bad. Okay, so it says sketch the graph for number 6 and sketch the general shape of the graph for number 7. I didn't read my own directions that I wrote last year. Okay, so you want to go off of the factored form to sketch this. So there's a root at 4 that's a double and a root at 5. So 1, 2, 3, 4, 5. And it's a positive A because they didn't tell you any different. So that means that we're going to start at the bottom. 4 is going to be our double and then go through 5. I definitely touched the x-axis there. I feel all of you judging my bounce. It hit the dot. Did it hit the x-axis? It's fine. Totally fine. Okay. I'm not stalling from number 7 at all. Okay. Number 7. We have irrational and imaginary. Oh, good. Okay. So before I start this, underneath, I'm going to write their conjugates because I like the visual of switching the sign. So if this guy exists, this guy has to exist. And if this guy exists, this guy has to exist. Okay, and I'm going to start with the very top left, X, switch sign, switch sign. Now I'm going to go to the conjugate of that, X, switch sign, switch sign. Then I'm going to go to the top right, X, switch sign. And then I'm going to go to the bottom right, X, switch sign. Now, when do I have to make sure I have the conjugate? Whenever there's irrational or complex, not with the regular ones. Okay, so we're going to start with a 3 by 3 for those two. But they're conjugates, so we don't have to do the whole thing. Mm -hmm. Okay, I want to go really slowly on the multiplying of this box right here because that's probably the hardest part of this problem, other than remembering that conjugates exist. Okay, so this box isn't bad. That's x squared. 2x, 2x, and 4. Okay, 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 okay. Now, we're gonna go really slowly on this box. It's a, whoop, close, hold on. So a negative times a positive is a negative. 2 times 2 on the outside is 4. And then 2 times 2 on the inside is 4. And then you're right, this becomes negative 4 times 2 because the square root of 4 is 2, which is negative 8. Okay, and I'm going to circle these because I want to remind myself that those will be combined. So I have y equals x squared plus 4x minus 4 for my first part. You guys see where the minus 4 came from? My two pink circles. I have 4 minus 8. I combine those together to get negative 4. So there's x squared from this box. So negative 2 root 2 times positive root 2 root 2 is negative 4 root 4. And then I took root 4 is 2. And then 4 times 2 is 8. I'm glad you asked. I needed to go over that slow. Okay, now I'm going to do a 2 by 2 for the imaginary ones over here. When they're conjugates, you get to skip those boxes, which is great. So negative 4i squared, the negative and the I squared cancel, and you get positive 4. So I have x squared plus 4 out of that piece. Okay, and now I need a 3 by 2. These are not conjugates, so I don't get to skip any, sadly. Also, it wouldn't make sense because it's not a square, but whatever, it's fine. Problem's got a lot of 4s in it. Oh, no, 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 no axes. We could actually do it. We're smart enough to do it at this point, but that's fine. It just said general shape. So this one is degree 4, positive a value. So general shape would be something like that. Yeah, honey. Oh, yes. You mean scroll up? Okay. Take a deep breath for 10 seconds, and I'm going to show you test topics. I just want to go over them and make sure that you know what they are. And if you could flip when you're ready to the stamp sheet side. Hmm, I don't want that. I don't want that. It's fine. Um, Give me 1 second. Apparently